So I think it's now time to start the webinar. So first of all, welcome everyone who joined this third topic of our webinar series. So my name is Fabian Ensle. I'm working at GAFAG, and the webinar series is happening within the course of the project called Earth Observation for Sustainable Development, and they're the forest management project. So we have a strong focus on forest monitoring, and we are using Earth observation data, so satellite data, to identify different stakeholders on changes in the forest cover, in forest cover densities, and for example, in biomass changes. And we have several use cases that are spread globally into different biomes. And this EO4SD forest management project, it is financed by the European Space Agency, ESA, and we are a consortium of multiple companies. These are shown here on the lower left-hand side. So we have CLS from France, Wageningen University from the Netherlands, then Hatfield from Canada, Indofor from Finland, and Caribou Space from UK. So we have spread, let's say, the webinar topics to our different counterparts. And the webinar series, they are provided in different languages. So there are French versions, Spanish sessions. Actually, one Spanish session for this one is in the afternoon. And today we are talking on tree cover and forest area mapping using Earth observation data. And I want to introduce the two main speakers of the day. So we have Rabin Skaudel. He is working at Indofor. He's a remote sensing and GIS expert. And as well, we have Saya Papunen from Indofor, and she's as well a remote sensing and GIS analyst. And they are participating in this EO4SD Forestman project and will introduce to you today the use of Earth observation for tree cover mapping. And I'm glad that we have now a lot of participants, and I'm happy now to hand over the floor to Ravins. Please go ahead.
Thank you, Fabian. Thank you for the introduction and very warm welcome to you all. And we are very grateful to have you all for this webinar on topics, tree cover and forest area mapping. So before we start this webinar, here are some housekeeping items I would like to talk. So first of all, there will be a Q&A session at the end of this webinar. So whenever you feel that you have some questions, please drop in your chat box. At the end of this session, then we'll collect your questions and try to answer. And this session is recorded, so we will publish this recording on our website so that if somebody missed these webinars or many others within this EO4SD project, so they can access anytime. Just to avoid any unnecessary disturbance, so by default your microphone and camera should be turned off, but in case if it's not, then please I request you to turn it off for this session. And like I said earlier, use your chat box whenever you have some questions. Please drop it so that we can discuss at the end of this session. Okay, so a little bit context about this project. I think Fabian, he already gave some brief intro about this project. So this webinar series is a part of Earth Observation for Sustainable Development. It's a project from European Space Agency. So main focus of the project is to support international finance institutes and their client states to harness the benefit of Earth observation data in their programs. So for these objectives, we have gathered a consortium team of 6 different teams, as you can see in the bottom half of the slide. So we in this project we build together to demonstrate the benefit and the utility of Earth observation data into different projects, IFI's projects. And also we'd like to cover different geographical region. And it's good to show that the applicability of EU data in their programs at various geographical scope. And also we want to show that this product, what we are delivering in this project, they are user driven. So they are at least adding some values to the IFIs and their client state. So for that, we engage as early as possible with IFIs and the client state to identify some of the areas where we could collaborate and where our product and services could benefit. For example, within this project, we have various kind of product. For example, tree cover product, tree cover density, forest area change, tree canopy density, near real-time monitoring. So these are the product, but it's not only this. We have capacity building, and also we exchange a lot of information throughout the project. So that's why it's like very important to us that our product and services is adding values to the program. And also, whenever we deliver something, we want to make sure that we are quality control. So with each of the product, we have quality assurance it. And also within the project, it's a big part of the project. It's technology transfer and capacity building. So one thing to highlight here that this kind of project will show some example how this EO data can be used. But to sustain this, there needs this capacity building and technology transfer. So to guarantee that, we have a big part of this project also has lots of capacity building programs. So for example, this webinar, we have workshop, we have online engagement, and so on. So as you can see here, we have a different topic covered within our webinar. For example, from 1 to 9, there are different interesting topics. We'll have webinar on each of the topics. And some of the topics, for example, webinar 1 and 2, they are already happened, but you can still access them by visiting to our website. Then you can find the recording. And if you can see the first one, introduction to EU product, basically it is a compilation of different kind of materials, online courses, guidelines, and so on. So they are like bundled into different topics. So you can access this anytime. And other interesting topics, you can get more details about each topic on our website. You can find different like exact timings and also the different kind of language. We are offering these webinars in 3 different languages: English, Spanish, and French. So now let's go into the topic. So just to give you the brief structure of today's presentation. So first, we like to introduce the bank use cases. As I mentioned, the main objective of the project is to demonstrate the benefit of EU data in the IFI's projects. So we want to show you something in brief, like where we are engaging, what kind of project. I will not go into the details, but giving some glimpse of these projects. And in the second part, I'll talk in brief about the tree cover and forest area products. And in the third part, I'll go a little bit more technical into what kind of data you need, how this workflow, how the workflow is like, what kind of data you need, what are the methodologies, and how you can generate this kind of product. And at the last of this session, then of course, we'll collect the questions from you and we try to answer. In this session also, we want to make this session a little bit interactive. So sometime in the middle of the session, we'll be asking you very simple and sometime a little bit technical questions. So the first one starts at the moment. So we are asking you at the moment where you are joining from. So simply you can provide the country you are located at the moment, and you can also see the result on your screen. This will just give a scope like where we are located for this webinar. Saya, did you already submit the poll?
Yes, the first poll should be now online.
Yes.
And there are a couple of answers already. There seems to be Germany, Kenya, and Netherlands. Eswatini, Indonesia, Serbia, okay.
Nice.
Nairobi. Okay. Tanzania.
All right. And thank you. And yes. And thank you. It's good to have people from a different part of the world. And it's one of our objective also is to cover as much as possible. So thank you again for all the participants for joining this webinar. So now we can go into the webinar. So Now I'll talk about the bank use cases, which we are engaging at the moment within this EO4SD project. So if you see the map, you can see the highlighted areas and the project. So these are the areas we are engaging at the moment. So they are mostly in the tropical side in all three continents. And now I'll talk a little bit brief. I'll give the brief introduction to each of these projects, not into the details, but again, just a brief introduction, what the main scope of this project and what the main objectives. So for example, this is the Amazon Sustainable Landscape Program. So this program is one of the largest regional program in the Amazon. It's a program funded by Global Environment Facility and managed by World Bank. So the program has transboundary sites, so it stretches across these Putumayo River Basin in Brazil, Peru, and Ecuador, and also Colombia. So this basin, it's one of the largest remaining intact forests in the world. So it's very important landscape. And the project aims to establish measures, initiatives that safeguard biodiversity, enable the integrated management of land resources, conservation of ecosystem in a very specific target location within this Amazon region. Next one, we are engaging in the forest project of Paraguay. This is also project led by World Bank. The project has a primary objective of enhancing forest governance through its support for the National Forest Institute and also its advocacy for the implementation of regulation that includes reforestation and landscape restoration measures. The program also focused in the private sector, so providing credit facilities along with the technical assistance to promote sustainable production practices and also establishment of sustainable management standards. In Ivory Coast, we have REDD Plus emission reduction program. This is in the Thai National Park. So this is also project led by World Bank and the permanent executive secretaries of REDD Plus. The program is aiming to implementing alternatives to deforestation by rewarding achievements in order to overcome the challenge of climate change and also reconcile economic development, fight against poverty, and preserve biodiversity. So the program target is the most forested area in the south, which also includes this Thai National Park. And this is the only remaining intact dense forest and most important carbon sink in the country. So this the region has very high significant importance in terms of biodiversity, carbon, and also the forestry. And the project is also implementing result-based payments that is expected to incentivize local communities along with the protected area management institutions to engage in more long-term sustainable forest management. In Republic of Congo, we have REDD Plus emission reduction program in the Shanga and Lukwala department. This is also project led by World Bank. The objective of the program are to make payment to the program entity for verified emissions reduction from especially reduction, deforestation, forest degradation, and forest enhancement. The activities primarily focus on providing support to forest companies in implementing long environmental impact logging practices, reducing emission from the palm groves, and also enhancing the management of a protected area. In Ethiopia, we have two projects, Oromia Landscape Forest Project and also Climate Action Through Landscape Management Program. These both projects are managed by World Bank. So the first Oromia Landscape Program, it's seeks to reduce deforestation by improving sustainable forest management throughout this Oromia regional estate. And whereas the CAM focuses on developing methods and capacity for the assessment of effectiveness of sustainable landscape management intervention using EU products. So this is interesting because one of the requirement within the project is that project indicator, that is NDVI. NDVI is the vegetation indices derived from the spectral band red and infrared. So in order to show the positive impact of the intervention, you need to have certain change in the NDVI. Obviously, that should be positive, but at the same time, you need to correct some of the climatic feature because NDVI has a very sensitive to the climate factors. So when you have NDVI as an indicator for the sustainable intervention, you need to correct the short-term weather effect, seasonality, and so on. So this is also one of the very interesting topic within this project. In Mozambique, we have a jurisdictional REDD Plus program. The Zambezia Integrated Landscape Monitoring Program it's a government initiative in Mozambique that is aiming to promote sustainable forest management and reducing deforestation in the province of Zambezia. So primary goal of the project is to improve well-being of the rural population, also ensuring the long-term sustainability. So it is the first program of the result-based payment for emission reduction in this in the country, in Mozambique. And two other projects in the Mozambique, MOZFIP, it's basically is aiming to improve the practices and enabling environment for forest and land management in the targeted landscape. MOZBio, while it focuses on strengthening capacity, financial sustainability, improving conservation area management, and promoting conservation compatibility and also rural development. So these are some of the objectives of such projects. In the Indonesia, we have Forest Investment Program. So this program is one of the largest investment by Asian Development Bank in community-based REDD Plus. So this was implemented by Indonesian Ministry of Environment and Forestry. So the aim focus on to contribute to the reduction of greenhouse gas emission in the special province that is West Kalimantan province of Indonesia. So these are the basically you see like these are the example of different cases which we are dealing. This also gives some kind of idea where this EU data can be used. So we are engaging with the projects, with the World Bank, ADB, and also with the state client state partners. So throughout the engagement, we are offering like a products, but also we are dealing some of the challenges together. So our main goal is also to demonstrate the utility of EU data in this project, but same time, this also gives the idea like there is really application of EU data in such project, and this should be even continue to further develop in the future. Okay, now once we have the some idea about the project we are dealing in the project, now we go into the product in brief. So before we go into the product, there are a couple of things we need to clarify. For example, the forest. So forest is defined using three key parameters such as area, tree height, and the canopy cover. So along with the minimum area and minimum height, the canopy cover, which is tree cover percent, is another crucial criteria for forest definition. So what it refers is that proportion of ground cover by the vertical projection of the tree crowns. But when you see the table, it's important to note that these criteria can vary across the country and region. So different country may establish different canopy cover threshold based on the specific ecological context. So this variation can be driven by the need to account the unique characteristic and the dynamics of each region ecosystem, or to meet the specific management goal of each country. So within this project, as you can see in the table, we have encountered a lot of already some variation within the definition. And this is very important because this will somehow link to the product we are dealing today. And some other items, deforestation and forest degradation. So deforestation and degradation of forest area, they are the major challenge to our environment and ecosystem. So monitoring and mitigating these issues has become like utmost importance in various policy projects aimed at the preserving our natural resources and also ensuring sustainable development. So in order to identify this deforestation hotspot, mitigate and monitor such issue, we need products such as like tree cover and forest area, because we need to quantify before we can monitor these things. That's why this tree cover and forest area cover, which we are talking today, these are really important. So tree cover, basically it provides the spatial distribution of tree. So it doesn't have to be forest. Tree can be anywhere. It can be a single tree. If you can pick up, that's the tree cover. Whereas the forest area is the tree cover when it's transferred into this forest criteria. So when the tree cover meets all the criteria of forest definition, that is called as forest area. So tree cover. So as I mentioned already, tree cover is a distribution and extent of tree cover within the specific region. So here you can see the product we delivered during the phase 1. So this is the tree cover map in Mozambique, 2 different regions. You can see this is derived from Sentinel-2, and you have the product 10 by 10 resolution. So each pixel is either tree or non-tree. All the pixel which represent tree, they are 1, and all the non-tree that can be anything except tree, they are like their number is like 2. They are classified as 2. And you can see the overall accuracy. So overall accuracy is pretty good, over 85%. So these are the product we delivered already during the phase 1, so last year. And tree cover density. So before we go to tree cover density, we need to understand tree canopy. So tree canopy cover refers to the proportion of area covered by the vertical projection of crown of tree. So for example, in a pixel, how much area is covered by the tree canopy. And when you convert this number into 0 to 1%, so how much of the pixel is covered by the tree canopy, and that numbers can be the tree CD. So it varies from 0 to 100%. So the information on the tree cover density is very vital for understanding and monitoring changes in the forest extent quality over time. And it helps to assess the impact of deforestation, afforestation, or forest management activity on overall health, sustainability of the forest ecosystem. In the slide, you can see another product we delivered during the phase 1. It's a TCD. It's basically same resolution, same details like in forest cover map. It's a 10 by 10 from Sentinel, but instead of forest and non-forest, now you have numbers between 0 to 100. So each 10 by 10 pixel now gives the amount of tree cover within that pixel. So it has not only give the extent of forest, now it's give more about the quality of forest you have within the same pixel. So that's why it adds more value to the tree cover data. And of course, our ultimate goal is forest area change, because we define the forest, and many policies, many projects, they use forest definition to monitor these changes and so on. So in this tree cover and the tree cover density, they are the fundamental for the quantifying forest area, as they provide the key insight into the presence of extent and also the health of the tree vegetation. So for example, you can see here the workflow. So tree cover density, it gives the canopy cover extent. So based on tree CD, you can filter the area which meets this canopy cover threshold, either is 10%, 20%, 30%, whereas the tree cover gives you some way to filter the area calculation. For example, most of the time it's 0.5 hectares. So when you filter this data, then you get the forest area. That's how you can see how you derive the forest area from these two topics, from these two products. And once you have two different forest area maps for 2 different time, at least for 2 different time, you have a temporality, then you can have a forest change map. For example, one in 2018, one in 2020, then you can compare these two data and you can analyze what happened within this area. Is there like more forest? There is deforestation? So you can do this change analysis. And as you can see, the application is immense. So you can use this kind of product in forest monitoring, land use planning, monitoring like conservation efforts, deforestation monitoring, carbon accounting, biodiversity conservation. And these are some of the few examples, but we have immense applications throughout the forest sector and also in other sectors. Okay, now we already went through the basic description. So what this product are and why they are important. Now we'll go into more into the technical side. So if you are interested how to derive this, now next section I'll try to explain what kind of data you will be using and what are the processes, how to get this data. So here you can see the workflow. It starts from assessing satellite imagery. Like here is Sentinel data, but it can be Lancet also, other data. Then we have the processing, different kind of processing. Then you classify the satellite data into tree cover map, and then tree cover map will go into the TCD. And once you have the TCD, then you can again do the similar filtering like I mentioned before and have the forest cover map. And this is very important to meet all this definition of forest in different countries, because without this this TCD product here, then these threshold about the canopy cover cannot be filtered. So basically you can have a tree cover map, but it not necessarily be the forest cover based on the country definition. So, and for example, here you can see tree cover mapping. So once, like I mentioned before, once you have the tree cover map for 2 different times, then you can do this kind of a temporal analysis. For example, forest change maps. You can see in the picture there are like tree cover and the other land. You can also account both the forest loss and forest gain. So yeah, and these all these analysis is at pixel level, so you are not losing any information. So when you use Sentinel data 10 by 10, the product are also from 10 by 10. And for tree cover mapping, here is the workflow. For example, first you need to assess the data, and there are different kind of platform to assess the data. Copernicus, Sentinel Hub, there are like Shapal, there are Google Earth Engine, so many platform where you can assess this data. Then once you assess the data, then there is certain processing you have to go. You have to do atmospheric correction, you have to do cloud masking, and so on. And of course, this depends on the area you are aiming, because in some of the tropical areas you have a cloud coverage for a long time. Then maybe you need to have a different set the time window where you want to collect the data. For example, you may not have all the data available within the time frame you are looking. So that time you have to even decide where to get the supplement data to have a good mosaic of this EO data set. And also you have to also take care of this phenology. For example, there are different seasonality, there is different kind of ecosystem across the world. So there is like leaf on leaf off period. So all these things, they impact on the spectral references. So the numbers in the band changes according to the phenology. So you have to also account this to select the good window for you for this analysis. And once you assess the data, you have the original band from the data, and you can also do additive derivative bands within the original. For example, you can calculate other vegetation indices, or also you have other percentile within the each band. So these all bands can give you like a different kind of data which you can analyze and find the good bands to predict your response variable. For example, you have 30 different bands, but it's sometimes it's not wise to use all the band for the creating of a in the regression modeling to predict something. Instead, you can do some kind of statistical analysis to find the best band that could be used to map the forest and non-forest or other products. So after you do this analysis, then you can do this. You can use only the selective bands. It will save your time and processing power, and you do the classification. So this process basically this is one of the process which should be which is common in most of the EO data processing and product development phase. So just to sum up the tree cover, so tree cover provide the spatial distribution of the tree, and it's not the forest cover. It's a post product which need to meet the forest criteria to be the forest. And so this tree cover, one thing is very important in the woody ecosystem like savanna, wetland, because the trees are really scattered there, or some forest outside forest, for example, urban forestry, agroforestry. So this product can give like most inside outside the forestry also. And now we go into the specific tree cover density. So tree cover density product is directly derived from high resolution satellite data. So that means Sentinel, Landsat, or whatever, and it provides information on proportional of canopy cover per satellite pixel in the range of 0 to 100%. So these I already mentioned. So each pixel will now represent the canopy cover from 0 to 100%. So tree cover, as I mentioned before, it's a tree canopy cover, which is the vertical projection of tree crowns to the horizontal earth surface. And it's indicate the presence and, like, for example, but tree cover on the other hand, it's just the indicate the absence and presence of tree. This is the workflow, as you can see. So tree canopy density information is derived from the multispectral high resolution data, satellite data, but you need a very good quality, very high resolution data. So for example, you can see here, we have a data here, and there is a very overlaid, the grid is overlaid over a very high resolution data. And with, for example, this is 10 by 10 grid, you can see here. So inside this each grid, you can see the forest cover. For example, here it can be close to 5%, but here it can be close to 100. So that's how you train the model. So based on this, you can either do manual delineation or automated segmentation. And once you derive this number each pixel, then the density information, then you can link up to the spectral values that is band for the output satellite data, that is Sentinel. So for this connection, you can use a regression model. So there are different kind of regression model. Random forest is one, cat boost is another one. So this regression model will link this canopy density information from each grid to the spectral band that you are using to derive this product. So and another important thing is that this TCD value, it strongly relies on the availability and the quality of our BHR data, high resolution data. And also there is a lot of variation. For example, it can vary regionally. So you need to, the training data set should be very much good quality, and all the training procedures should be like more accurately in order to have very high accuracy of this product. For example, here you can see this is the product, a tree cover density product in Mozambique. So this is again derived from Sentinel, and you can see each pixel has from 10 to 100% information about the tree cover, tree canopy density. So in conclusion, so tree cover density, it's information on the state of forest and also the quality of forest. It plays a crucial role in various applications and themes related to forest assessment and management. It is also particularly important for applying forest definition and determination of the extent and quality of forest. And one thing is that tree canopy density shows a natural sensitive toward phenology and radiometric influences. Like for example, I mentioned previously that you need to have good quality of data sets, and the magnitude of the tree canopy density also varies strongly. It relies on the availability and the quality of adequate satellite input and also reference data, and this can vary regionally. And some of the aspect, for example, extreme weather events like cloudy contents, for example, haze, this can really impact the accuracy of the tree canopy density. Yeah, so I hope that you got a good idea. So if you have some questions, please drop on your chat box. Now we will go into the topic forest area and change. Saya, before that, can we drop a poll?
Yeah, sure. We can launch the next poll, which would be the following. So the question is, would a tree cover density product be beneficial for your work? And if so, in what ways could it be useful?
All right. So you can reply this by typing some of your answer.
Okay, there's one response as of now. It's simply yes. Couple of more. The afforestation progress mapping.
Okay.
Or forest cover monitoring of forests. Okay. Agroforestry monitoring. Forest valuation. Okay.
Good. So it's good to have, like, you already have some kind of idea where this product can be used. Now I think Saya, so would you take this chapter of forest area and change? And yeah.
Yes, thank you, Robins. So I will take it from here. Okay, so we already briefly went through the forest area and change product, but we would still want to highlight that forest cover is different from tree cover. So for the forest cover map, we need to apply some kind of definition of forest, whether it be a national definition or FAO definition or something along those lines. So we have to know the parameters with which we define a patch of trees as a forest or as trees outside of forests, for example, in urban areas or in agricultural settings. For example, in the REDD plus process, all stakeholders apply a forest definition complying with the framework definitions provided in the Marrakesh Accord. And we can move on to the next slide. Here we have the process of creating forest area map. So as Robins explained earlier, we can do that by using the TCD. First, we have identified the tree covered areas and the tree cover density. And by applying a certain forest definition, which we need or want to use, we can do the binary conversion to get the forest area. And we can, of course, apply even more parameters as shown in the figures below. So, for example, we can use the parameter of width of more than 20 meters, 30 meters, whatever we want to use, minimum size of the patch, and minimum TCD, etc., etc. Then, so basically the forest area and change products form the basis for determining gross deforestation rates and also for the detection of forest regrowth or replanting, and they can be used as the benchmark for deforestation or disturbance detection in early warning systems. And there are two related capabilities. So the forest area stays, it shows the extent of the forest at a given point in time and takes into account the country-specific forest definitions, as discussed before. And in this, all the forest types are consolidated into a single forest category, and other land use or land cover types are aggregated into a non-forest category. And the forest area status is then derived from the high-resolution satellite data. Or then the corresponding forest change product is derived by a time series image classification approach, by which we can then identify stable and non-stable forest areas.
Saya, at this point, do we have the final poll?
Yeah, we could actually launch at this point. The last poll. So I will launch it now. And the question is, for what purposes can the forest area and forest area change product be valuable? No responses yet. Okay, emission monitoring. Yeah,
Yes.
carbon emissions. Sustainability criteria. REDD plus reporting, yeah. Measuring deforestation, yes. Forest monitoring, forest health and restoration. Okay. Change maps, of course, yes. Operational applications. Monitoring forest degradation. Okay, there are quite many good answers here. So I think we can then move on to the final parts of the presentation. So here are a couple of places where the forest area and change product can be used as input. I think we actually briefly went through this earlier, but there are some points which you also brought up in the poll. So, for example, REDD plus, analysis of degradation, deforestation, forest landscape restoration. I think restoration was also brought up in the poll. Then there's, for example, identification of high carbon stock forests, forest management and planning, also in the operational level, and so on. And let's move on to the next one. And then we have a slide about the ancillary data delivery related to the monitoring and reporting. So we have different kinds of analytics reports, metadata. So for reports, we can, for example, have the documents of the product generation, and they are provided for each team and product, and describe the service and service operation. Then we have spatial analytics statistics, which are based on these products which we have generated, and we have the ancillary data from the GIS operations, which can be presented in figures, tables, charts. And then, of course, the metadata, so information about the geospatial datasets, and we have a description of each dataset, and the metadata for these products is INSPIRE compliant. We can move on to the next. Then a couple of slides about verification for the forest area and change product. So the verification process is done in 2 stages. So we have a 2-stage sampling design. There are the larger primary sampling units, and inside the primary sampling units, we have the secondary sampling units. And for both, we do a random selection. And this is quite a cost-efficient, effective, and unbiased approach to verifying the accuracy of the product. And validation of forest maps. So this can be done by comparing the mapped classes to the actual real land cover types on the ground. And that can be done either using field plots or using very high resolution satellite imagery. And these validation points are then analyzed in a single confusion matrix. So we are cross-checking the map class and reference data. Do they correspond to each other? And different kinds of accuracy metrics are calculated. Maybe the easiest or most general one to be used is the overall accuracy, which describes the overall the proportion of the reference sites that are mapped correctly and we also have producers and users accuracy. And we can calculate the confidence intervals and other accuracy related data. So here we have a slide displaying the confusion matrix with reference data in the columns and the classification as the rows. And here we have the mentioned accuracy metrics. So the overall accuracy here is around 89%. Then we have also calculated the kappa value, which basically measures the agreement between the two raters, each classifying the items into mutually exclusive categories. And then the producer's accuracy, which is the probability that a certain land cover of an area on the ground is classified as such, and the user's accuracy, which on the other hand tells us how often a class on the map is actually present on the ground. So it is a measure of reliability of the classification. And just briefly an application example. So in Cameroon, GAF have contributed with the assessment of activity data and emission factors and transfer of capacities and technologies. And for the production of the activity data, a multi-temporal analysis of satellite imagery was done, and using Landsat data, but as well optical and radar imagery from Sentinel-1 and 2. And the final activity data that was derived was change in forest area. And this analysis has aided in the estimation of deforestation and degradation, which in turn, in combination from the emission factors, which are derived from field measurements, have aided in the estimation of forest-related emissions. And the results of the work have been transferred through workshops, on-the-job and field service.
Thank you, Shaya, for explaining these quality assurance and these are the things which we deliver. For example, when we produce some product, for example, tree cover density, we have a certain, like Shaya described before, we do the quality assurance and quality control. So we have like the accuracy matrix, and same time we also offer these Inspire standard metadata that is also delivered within the product. So I think now we have covered. So I give this floor now to Fabian for the Q&A session.